Greetings, M squared here. Today we're going to solve some systems by using elimination, sometimes called addition and subtraction. I basically just do the addition part because I don't bother with subtraction because I can always make things opposites and then add them. Makes it a little bit easier. So these are the steps. I'll zoom in for a minute. So I want to make sure you know what the steps are. So we're going to line up our x's, y's, and equal signs and numbers so that the equations are all lined up. So kind of like that. See, x's are lined up, y's are lined up, equal signs are lined up, numbers are lined up. Then we're going to choose a variable to eliminate, and sometimes it's easier to choose one than the other. These are pretty basic ones today. They're not really difficult, except for one contains a fraction. And then once you get the two equations so that the variable you choose has coefficients that are opposites. So let's remember what coefficients are because I'm going to use that word. Coefficients are the number part of a product. So if I have a 5x, the 5 in the 5x is the coefficient. Okay, so just the number that is multiplied by the variable, not the x, just the 5. Okay, so we want to make sure that when we set up our equations that what the variable that we're going to get rid of them, the coefficients are opposites. So what are opposites? Like 3 and -3, 1 and -1, that kind of thing. Those are opposites. And after that, after we get them lined up and opposites with one of the variables, we're going to add the two equations. Then we're going to solve that equation. When we add them, something's going to be eliminated. That's why it's called elimination, because we're going to eliminate one of the variables. It's going to cancel out. We solve that, and then we substitute it back in. So just keep in mind those steps. Okay, so we're going to go up here, and we're going to do this one. So are they lined up? Check. Do I have a variable that has opposite coefficients? Well, this coefficient is 1, that's 2. 1 and 2 aren't opposites. But this one is 1 and -1. Remember, if there's not a variable there, there's a 1. Those are opposites. 1 and -1 are opposites. Once I find a variable that has opposites, I add them. If I didn't find it that way, I would make them opposites. So now I'm going to add the two equations. So x plus 2x is 3x. Y plus a -y cancels out. That's a 0, not a 0y. I mean, it is a 0y, but don't put y down. Some people think it's just a y. It's a 0y. 0 times y is 0. I'm adding 7 and 2 and getting 9. So now I solve this equation, and it's very easy because one of the variables is gone. So usually all you have to do is, right, we're just dividing. So x equals 3. 9 divided by 3. So now over here, this is where I'm going to put my answer. Remember, when we solve systems, the answer is always a point, a coordinate, an ordered pair. So I think my x is 3. I'll double check later to be for certain. So now I know x is 3. So now I go back up to the original equation, and I'm going to put a 3 in for my x. So it says x plus y equals 7. I'm going to say, oh, but x is 3, so I'm going to take the x out and put the y in. 3 plus y is 7. So if I subtract 3 from both sides, I get y equals 4. And so now I think that y is 4. Now this is my check. Always check, because then you'll be 100% sure that you're right if it works out. So I'm going to say 2 minus y, 2x minus y equals 2. This is my check into the second equation. Notice I didn't use the one I just used, because if I made a mistake there, it might show me that I got it correct when I really didn't. So I always want to use the other equation. And I just have, usually I'm systematic about it. I use the first one to find the other variable, and then I use the second one to check. So I'm checking. So what is x? It's 3. What is y? It's 4. So I just put that 3 in for that x, that 4 in for that y. 3 times 2 is 6 minus 4. 6 minus 4 is 2. Yes, indeed, 2 equals 2. That's my check. So now I know I'm 100% correct. It's a nice thing to know that. Okay, moving on to this one. X's, y's equals numbers, all lined up. Are these opposites? They are indeed. So I'm going to add. By the way, I'm not going to show it on this video, but if all of your variables cancel out, remember, just the same as substitution, if the x's and the y's happen to cancel out at the same time and you're left with like 2 equals 3, then you would know that that's not true. That would be a no solution. That's the same as parallel lines. But if you got it to where it was true, so this would be a no solution, parallel lines. But if you had something like -5 equals -5 after the variables cancel out, or 0 equals 0, then that's an infinite number of solutions. So just keep in mind that those are options. Oh, you couldn't even see that. I'm sorry. So this would be a no solution. This would be an infinite number of solutions. Okay, none of those today, but it can happen. So I'm going to add, because I have two coefficients on an x, and this could work for y's too, that are opposites. So that cancels out. That's 5y, 2y plus 3y. Negative 6 plus 1 equals negative 5. And please, if you're not good with your negatives, please just get a calculator out, because you don't want to get them wrong. So I divide by 5 to get y alone, and I find that y equals negative 1. So over here, my answer, I put it in the y spot. Remember, x always goes first, then y. Y equals negative 1, so I put the negative 1 there. Now I'm going to use my first equation, 2x, whoops, that's x. 2x plus 2y equals negative 6, but instead of y, I'm going to put a negative 1. Okay, so to rewrite that so it's a little prettier, I multiplied 2 and negative 1, I get a negative 2. So I'm going to add 2 to both sides, because remember, my goal, I found y, I need x, I'm trying to get x alone. So I get rid of the thing that's being added or subtracted first. That gets me a 0, I get negative 2x equals a negative 4, and when I try to get x alone, I divide by negative 2, I get x equals 2. So then I'm going to come up here, and I'm going to put a 2. Then I'm going to check, here's my check, into my second equation, 2 times x plus 3 times y. My goal is to get 1. So I put a 2 in here, a negative 1 in here. What's 2 times 2? 4. 3 times negative 1, negative 3. What's 4 minus 3? 1. That's what I thought I'd get. Now I know. I am 100% confident that my answer is correct because it worked in both equations. All right, let's try this next one. Now this one, the variables aren't opposites. So I'm going to show you, you could get rid of x's. In fact, if I was doing this on my own, I'd get rid of x's because it's easier, because all I'd have to do is multiply this whole equation by negative 2. If some of you are wondering, why would you multiply an equation by a number? Well, we can multiply any old equation. So if I said, what, 3 equals 3, that's an equation. You would agree 3 equals 3. But I could multiply both sides by anything I want. As long as I multiply by the same thing on both sides, I still get something that's true. So it doesn't compromise the solution set. So that's used a lot in math, where you multiply an equation by something to help you solve it. So we're going to multiply, we could multiply x, this whole top equation, by negative 2. But I want to show you how you can multiply both equations by something, because you need to know how to do that maybe. This is a little level up. So I'm going to decide to eliminate y's instead. Again, if I wanted to eliminate x's, I'd multiply the whole first equation by negative 2. But I'm going to eliminate y's. So to do that, I need opposite coefficients. Well, right now they're 2 and 5, but it's a negative 5. So if I multiply this top equation by 5, that would get me a 10y. And if I multiplied the bottom equation by 2, that would get me a negative 10y, and then I could eliminate them because the y's would be opposite. The coefficients on the y's would be opposite. So I'm going to do that over here. So 5 times x is 5x. 5 times 2y is 10y. 5 times 4 is 20. So I just multiplied the top equation by 5. Now I'm going to multiply the bottom equation by 2. So 2 times 2x is 4x. Then I get a negative 10y and a negative 2. Now they're opposites. I can add. So 20 minus 2, or plus a negative 2, is 18. This cancels. 5x plus 4x is 9x. And if I get x alone, I get x equals 2. So I know now, or I think, I'm pretty sure, x is 2. I won't be sure 100% until I check it back at the end after I find my y. So now I have to find my y. I always use an original equation. I never use one that I've multiplied in case I made a mistake. So I'm going to go back up to my original equation, and I'm going to say x plus 2y equals 4. But instead of x, I'm going to put a 2. That's why I put that little line out there, because I need to put my x in there. So now I'm going to subtract 2 from both sides. I get 2y equals 2, so y must equal 1 if I divide by 2. Okay, so now I'm going to check. Is that true? So here's my check. Does 2 times x minus 5 times y get me a negative 1? Okay, well, what was my x? What was my y? Right there, x and y. 2 times 2 is 4. minus 5. What is 4 minus 5? Negative 1. Yes, indeed, it works. So now I am 100% sure that it is correct. Okay. Let's do this one. Which should I eliminate? Well, I could get rid of the x's. I just multiply the bottom by 2, or I could get rid of the y's. I'd have to multiply it by negative 2 to get the opposites. But these are opposite signs, so I would choose to just multiply this one by a negative 2. So I'm going to multiply that by negative 2. Negative 4x minus 2y equals negative 4 when I multiply all of that by negative 2. This one I don't have to multiply by anything. Did I just say negative 2? I meant positive 2. I think that's why I said let's get rid of the y's, because then we'd have to multiply by positive 2 and not negative. Oh well. Silly me. Okay, here we go. We didn't have to do anything to the bottom equation because we have opposites, so now I'm just going to add. So 4x plus x is 5x. Those cancel, and I get a negative 1. So if I divide by 5, whoops, positive 5, I get x equals negative 1/5. Now, a lot of people would freak out when they get fractions, but if I ever get a fraction and I think, oh, did I do something wrong? I just go back and check. Yes, that's right. I got a 5. I got a negative 1. I can't find a mistake. I always would check, so I'm thinking that's it. So we're just going to keep moving forward, pretending that we're good, and we might be. We're gonna know because we're going to check at the end. So I'm going to take the original first equation. I'm going to say 2 times x plus y equals 2, and I'm going to substitute negative 1/5 in. Remember, when you multiply by fractions, it's numerator times numerator, denominator times denominator. So I have 2 times negative 1, which is negative 2, and then 1 times 5 is 5. So 2 times negative 1/5 is negative 2/5. I have to get my y alone, so I'm going to add 2/5 to both sides. And 2 plus 2/5 is 2 2/5, but if I wanted to make that a improper fraction, I'd like to do that. I take 5 times 2, 10 plus 2, so I get 12/5. So now I think it's 12/5. But I can be sure by checking. So I'm going to check into my second equation. So I'm going to have x, that's my negative 1/5, minus 2 times my 12/5 equals negative 5. So, got to multiply this. Remember, numerator times numerator, denominator times denominator. So I get 2 times 12, which is negative 24. 1 times 5, which is 5. So negative 1/5 minus 24/5. Well, negative 1 minus 24 is negative 25/5. And if I divide 25 and 5, I get 5, negative 5. So yes, negative 5 equals 5. So I am 100% confident that that is my answer. Beautiful. Okay, now I'm going to do a couple word problems. So I am going to have you look at this picture. So we're talking about a florist. There's a florist, and she's making bouquets. She's making regular bouquets and mini bouquets, and she's using roses and peonies in her bouquets. If you don't know what a peony is, look it up. It's kind of a pretty little flower. Okay, so for each regular bouquet, it takes 5 roses and 11 peonies, and for each mini bouquet, it takes 3 roses and 5 peonies. So I'm going to look over here, and I'm going to see the word problem, and I'm going to definitely notice that she has 118 roses, 226 peonies, and they're asking a very particular question. How many of each type of bouquet can the florist make? When they're asking you, especially in Algebra 1, most of the time when they're asking you the question, that tells you what your variables equal. And you always want to know what your variables equal before you get started. So I'm going to say let x equal the number of regular bouquets. And let y equal the number of mini bouquets. So, with that in mind, I've helped you out a little bit. You're going to need a rose equation and a peonies equation. So when I look over here, I notice that there's 5 roses in the regular bouquets and 3 roses in the mini bouquets. And I know that my rose equation is going to have something with the regular, something with the mini. So if I have 5 roses and X represents the number of regular bouquets, then and 5 is each bouquet, then 5X represents the total roses that I use for X number of bouquets. So this is the total roses I use for the regular bouquets. And then there's 3 roses in this one. So 3Y. 3Y represents the roses I would use for all of the mini bouquets, because Y represents the number of mini bouquets. So when I come over here, if I take all of the roses I'm using for the regular bouquets plus all of the roses I'm using for the mini bouquets, it equals a total number of roses that I have. So that's my roses equation. And I do the same thing with the peonies equation. So this is, remember, this one represented my X and this one represented my Y. So I'm going to say 11 times X, which is all the peonies for the regular bouquets. And then 5 times Y, which is all of the peonies for the mini bouquets. Then it equals a total of 226. Now I'm just going to set it up and let you solve it. That's what I'm going to do, because I have to find my calculator first. Oh, wouldn't you know? There it is. Okay, sorry. I'm going to solve this system of equations. Now, I got to get opposites. I don't see opposites. What would be the easiest? Well, I could multiply that by 11 and that by -5, or I could multiply this by 5 and that by -3. It doesn't matter which one you choose to do. I'm just going to do Y's. So I'm going to multiply this one by -5 and this one by 3. That's just what I'm going to do. Okay, so I'm going to do that. 5 times 5, -5 is -25x. That's -15y, and to do 118 times 15, I'm getting my handy-dandy calculator. I'm sorry, times 5. Getting my handy-dandy calculator out. That's a -590. -5 times 118. Okay, so now I'm going to multiply everything by 3 in the second equation. So 3 times 11 is 33x. Then that's 15y. And that's going to equal 678. And then I'm going to add them. So, let's see. This is going to be 88. And that's just going to be 8x. And this one, cancel it. Oh, did I seriously put 5 there? And you're wondering, why did she put 5 there? Because 3 times 5 is definitely not 5. Okay, here we go. It's good to find those little mistakes before you finish. So if I divide both sides by x, x equals 11, and didn't I say I wasn't going to do this, and here I am doing it. So what does that mean if x equals 11? Well, what did x represent? X represented the number of regular bouquets. So with this amount of flowers, the florist can make 11 regular bouquets. Now to find y. So y is the other one. So if I just put 11 in there, I get 11 times 5 is 55. Plus 3y equals 118. And if I take 118 and I subtract 55, I get 63. So I get 3y equals 63. And if I divide by 3, I get 21. So 21 mini bouquets. So if I was graphing that, oh, you couldn't even see that. If I was graphing it, I would get that as my intersection point, but you probably don't want to graph it because 21's way out there. And so we were solving by elimination in this one. Whenever I do a word problem, I make my students write it. She could make, I know we're assuming it's a she, she could make 11 regular bouquets and 21 minis. So you just need to write a sentence because in a word problem you want it to kind of make more sense like that. Okay, this one's a little bit easier. It's about snacks and drinks. So 2 friends go to a baseball game. Each group plans to share snacks. So what is the price of 1 drink and 1 pretzel? What is the price? That's what they're asking. So X and Y are going to represent the price. So we have 2 different things. So we're going to have the price of a drink and the price of a pretzel. So price of a pretzel, price of a drink. Okay, so it says 3 drinks 2 pretzels, $16. So if I take the number of drinks and I multiply it by the price of a drink, and I take the number of pretzels and multiply it by the price of a pretzel, okay? If I have 2 times X, this represents all the money I spent on pretzels. This represents all the money I spent on drinks. And together, I spent a total of $16. So the money I spend in drinks plus the money I spend in pretzels equals the money I spent. So for this one, maybe you can figure it out already. 5y plus 5x, because I got 5 drinks and 5 pretzels, equals 31.25. So you'll notice there's a system. I need to solve it. I need opposites. So what are you going to do? Well, I think I'll just get rid of x's. It doesn't really matter, but then I get 10s, and 10s are nice. So I'm going to multiply this one by 5 and this one by -2, so I get a -10. So that's a 15y plus 10x equals, what is that, 80, I believe? And then -10y minus 10x equals, what is that, 62.50? We're going with it. And now I'm going to add. I get 5y equals, and what is that, 50 cents gets me to 63, 7 gets me to 70, so I'm thinking that's 17.50. 17.50 divided by 5, and that gets me y equals $3.50. Now, what was y? The price of a drink. A drink, capital, a drink costs $3.50, and a pretzel, we're going to figure that out, costs, let's figure it out. So we're going to plug y back in. So we're going to take one of our original equations, our 3y, that's 3 times 350, plus 2x equals 16. So 350 times 3 is 1050. Whoops, plus 2x equals 16. And when I subtract 1050 from both sides, 50 cents gets me 11, and 5. I think that's what we get, 16 minus 1050. So if you divide by 2, 2 goes into there 2 times, what is that, 275? I don't know, let's see, 550 divided by 2 is 275, yep. Then we come over here and say 275. And then I'm going to show you how to check it in your calculator, because when I do a word problem like this, I check it in my calculator. So I'm going to check this one. So remember, y was the price of a pretzel, which I said is $2.75. So I'm going to take 5 times $2.75, and that parenthesis, that's the cost of pretzel. And then I'm going to say plus, because it says plus, 5 times the cost of the drink, because that was the number of drinks. And if it equals $31.25, oh, I'm right. And I am right. Okay. That is it for solving systems of equations by elimination. Good luck with all of that. M squared signing out.